This is SpaceTime Series 27, Episode 132, for broadcast on the 1st of November 2024. Coming up on SpaceTime, could Betelgeuse actually be two stars? Richard Branson to co-pilot the first manned flight for Space Perspective. And they haven't put anything in orbit for half a century, but Australia is looking at developing more spaceports. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has raised the possibility that the red supergiant Betelgeuse may actually be a binary star system. Now, if that's the case, it means the star may not be on the brink of exploding as a supernova after all. Located between 530 and 643 light-years away, Betelgeuse is the brightest star of the constellation Orion, the 10th brightest star in our night skies, and one of the largest and most luminous stars visible with the unaided eye. Commonly called Betelgeuse, don't say it 3 times, its name, before centuries of tortured mispronunciations, started out as Betelgeuse, meaning hand of the big man in Arabic, the big man being Orion the Hunter. Betelgeuse began its life about 10 million years ago as a spectral type OB blue star, making it one of the largest and most luminous main sequence stars. Calculations of Betelgeuse's mass range from slightly under 10 to a little over 20 times that of our Sun, with some 100,000 times the Sun's brightness and around 1,100 times its diameter. If Betelgeuse were at the location of the Sun at the centre of our solar system, its surface would extend almost out as far as Jupiter, engulfing the orbits of Mercury, Venus, Earth, Mars and the main asteroid belt. It's now a bloated old semi-regular variable red supergiant. Red supergiants are the largest stars in the universe in terms of their volume. Eventually, they explode as core collapse supernovae, ending up as neutron stars or stellar mass black holes. And Betelgeuse is expected to explode any day now, which in astronomical terms could mean 1 million years from now, or it could mean tomorrow. When it does explode, it'll temporarily outshine all the other stars in the galaxy, and it will be clearly visible in the daytime sky here on Earth. The last star seen by humans to go supernova in our galaxy was Tycho's star. That was way back in 1572, long before the invention of the telescope. However, these new observations mean Betelgeuse may not be on the brink of exploding after all. Astronomers can predict when a star will die by effectively checking its pulse. What happens is stars get brighter and dimmer, pulsing like a heartbeat, counting down to an eventual supernova explosion. However, the new observations on Betelgeuse reported in the Astrophysical Journal suggest that the pulsing of this star could be caused by an unseen companion star orbiting Betelgeuse. Formerly named Alpha Orion b, this tentative second star would be acting like a sort of snowplow, orbiting Betelgeuse and pushing light-blocking dust out of the way, temporarily making Betelgeuse seem brighter. That's the pulse. The study's lead author, Jared Goldberg from the Flatiron Institute, says he's already ruled out every other intrinsic sort of source for variability, and the only hypothesis that seemed to fit the observations is that Betelgeuse has a companion. Now, to back that up, Goldberg and colleagues observed that Betelgeuse had 2 heartbeats, one that pulses on a timescale of a little longer than an Earth year, and one that pulses on a timescale of about 6 Earth years. One of those heartbeats is Betelgeuse's fundamental mode, a pattern of brightening and dimming that's intrinsic to the star itself. If the star's fundamental mode is its long-scale heartbeat, then Betelgeuse could be ready to blow sooner than expected. However, if its fundamental mode is its short-scale heartbeat, as several studies suggest, then its longer heartbeat is a phenomenon called a long secondary period. In that case, the longer brightening and dimming would be caused by something external to the star itself. Now, scientists still don't know for sure what's causing the long secondary periods. But one of the leading theories is that they arise when a star has a companion that's circling it and barrels through cosmic dust being produced and expelled by the primary star. This displaced dust would alter how much starlight reaches an observer on Earth, changing the star's apparent brightness. Goldberg and colleagues explored whether other processes could have caused the long secondary period, such as the churning of the star's interior or periodic changes in the star's powerful magnetic field. After combining direct observations of Betelgeuse with advanced computer models that simulate the star's activity, the authors concluded that a secondary star is by far the most likely explanation. Goldberg says that if there's no companion, it means that something way weirder must be going on, something impossible to explain with current physics. The authors have yet to explain what the so-called Beetle Buddy is, but they assume it's a star about twice the mass of our Sun. A more exotic hypothesis is that the companion's a neutron star, the core of a star that's already gone supernova. However, if that's the case, you'd expect to see evidence of this with X-ray observations, and they're not showing it. So the authors will now try to take images of Beetle Buddy with telescopes, as there's a potential window of visibility around December the 6th. That's just a month away. They'll need to confirm that Beetle Buddy really does exist, since their results are based on inference, not on direct detection. Needless to say, we'll keep you informed. This is SpaceTime. Still to come, Richard Branson to co-pilot a new stratospheric balloon flight. And although we haven't launched an orbital mission for over half a century, Australia is looking at developing even more spaceports. All that and more still to come on SpaceTime. It's been announced that Virgin boss Richard Branson will co-pilot Space Perspective's first stratospheric balloon flight. Last month, the Florida-based company undertook an unmanned test flight of their high-altitude balloon and gondola, which will eventually take space tourists to altitudes of over 100,000 feet. That's 30 kilometres above the ground. Now, although that's nowhere near the edge of space, it's high enough to allow occupants to see the curvature of the Earth under a black sky, even in broad daylight. The system uses a hydrogen-filled balloon and a pressurized gondola. The 6-hour stratospheric flight will avoid the high G-forces of rocket-powered space tourism flights, providing a far more gentle experience that will include meals and Wi-Fi. It'll offer up to 8 passengers at a time breathtaking views through panoramic windows. And there's no weightlessness, so no risk of space sickness. Branson, who undertook record-breaking Atlantic and Pacific Ocean balloon crossings and established the Virgin Group, already operates Virgin Galactic, which takes space tourists to the very edge of space. This is SpaceTime. Still to come, Australia looking at developing more spaceports, and the giant spiral galaxy M31 Andromeda, the Crab Nebula M1, and 3 meteor showers are among the highlights of the November night skies on Skywatch. Although Australia hasn't put anything into orbit since the glory days of the Woomera rocket range over half a century ago, plans are afoot for new spaceports, with both Western Australia and Queensland the latest to make proposals. Spaceport Australia has announced plans to construct a spaceport on the Cape York Peninsula in far north Queensland. The company's already announced a $30 million deal to acquire 2 air surveillance radars for the project. The deal would see the technology arrive by the end of 2026. Former Australian Prime Minister Scott Morrison has been appointed chairman of the new company. Meanwhile, on the other side of the country, the Western Australian government appears to be hinting at the idea of establishing its own spaceport. The government's new space industry strategy claims the state's vast coastline and minimal air traffic would make it an ideal location for a space launch and return facility. It's not the first time a spaceport has been proposed in Western Australia. Another company was looking at polar rocket launches from Albany on the Great Australian Bight back in 2022. But the new plan claims Western Australia would be an ideal location for communications, tracking and launch facilities, offering a range of advantages and optimal environmental conditions. The statement claims the state's clear skies, large arid areas, minimal radio interference, and location around 120 degrees apart in longitude to Western Europe and North America would provide an ideal world-class location for hosting space ground infrastructure. And of course, the state already hosts dozens of national and international facilities that support global coverage of space assets, space communications, as well as space situational awareness and positioning navigation and timing facilities. The Western Australia space industry strategy has already seen over $1 billion invested or committed to Western Australia's space sector since 2018. Australia is already home to 5 spaceports. There's Equatorial Launch Australia's Arnhem Land Space Centre in the Northern Territory, Gilmore Space Technologies Orbital Spaceport in North Queensland and Bowen, Southern Launch's Orbital Whalers Way Facility and Suborbital Coonimba Test Range in South Australia, and of course there's the Woomera Rocket Range, also in SA. This is Space Time. And time now to turn our eyes to the skies and check out the celestial sphere for November on Skywatch. High in the northern skies of November, you'll find the constellation Pegasus, the Mesopotamian and Etruscan mythical winged horse, who was born from the blood of Medusa the Gorgon after she was slain by Perseus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, located some 690 light-years away. It's estimated to have about 185 times the Sun's radius and 12 times its mass. Epsilon Pegasi, together with the stars Markab, Al-Janib, Shahid and Alpha Andromedae, forms the asterism or pattern of stars known as the Great Square of Pegasus, a bunch of bright naked-eye stars shaped like a square. One of the stars in this constellation is 51 Pegasi. 51 Pegasi is a Sun-like star located 51 light-years away. On October 6, 1995, astronomers announced the discovery of an exoplanet orbiting the star. It was the first ever confirmed detection of a planet orbiting another star. The planet has around half the mass of Jupiter and is thought to be a gas giant. But it wasn't what scientists were expecting. The planet orbits the star in just 4 Earth days. That's much closer than Mercury's 88-day orbit around the Sun. Because it orbits so close to the star, 51 Pegasi b as it's called, experiences temperatures estimated to be around 1200 degrees Celsius. Now, at the time of its discovery, this close distance was not compatible with theories of planetary formation, and it resulted in a lot of discussion among scientists about the idea of planetary migration. However, since its discovery, numerous other so-called hot Jupiters have been detected, pretty much confirming planetary migration to be real. By the way, a light year? Well, that's the distance a photon can travel in a year at the speed of light, which is some 300,000 kilometres per second in a vacuum, and the ultimate speed limit of the universe. Also visible in Pegasus is the M15 or NGC 7078 globular cluster, which is located around 33,600 light-years away. Globular clusters are tight balls containing thousands of stars, which are all originally formed at the same time out of the same molecular gas and dust cloud. M15 is estimated to be around 12 billion years old, making it one of the oldest known globular clusters. And it contains around 100,000 stars, making it one of the most densely packed globular clusters in the entire Milky Way galaxy. Its core has undergone a contraction known as core collapse, and it has a central density cusp with an enormous number of stars orbiting very rapidly around what appears to be a central black hole. M15 also contains at least 112 variable stars, 8 pulsars including 1 double neutron star system, and the first ever planetary nebula found in a globular cluster. Now, if you're in or near the Northern Hemisphere and away from city lights, you'll notice a fuzzy patch of light right next to Pegasus. This is the giant spiral galaxy M31 Andromeda. Andromeda is the biggest galaxy in our local galactic group. Located some 2.5 million light-years away, Andromeda consists of more than 1 trillion stars, around twice the number found in the Milky Way. And it's huge, some 220,000 light-years across. Based on current estimates, Andromeda appears to have more older stars than the Milky Way. It also has far less new star production going on than our galaxy. And the rate of supernovae in the Milky Way is also about double that in Andromeda. Andromeda is surrounded by a large, massive halo of hot gas and plasma, estimated to contain at least half the mass of the stars in the galaxy. This nearly invisible halo stretches about 1 million light-years from its host galaxy. That's almost halfway towards the Milky Way. Using a good pair of binoculars or a backyard telescope, you'll see dark dust lanes in Andromeda's spiral arms, and you'll see its bright central galactic core. Now, over time, Andromeda will become a lot clearer. That's because it's getting closer. You see, the Milky Way and Andromeda are expected to collide in about 3.7 to 4.5 billion years from now, the two spirals eventually merging to form a new giant elliptical galaxy. What that means for the future of the Earth, the Sun and our solar system is a matter of great ongoing debate. The gravitational tidal perturbations from the encounter could rip our solar system apart, or even fling us out into intergalactic space. At this stage, only time will tell. Now, looking to the east and slightly south of Pegasus, you'll see the ancient constellation of Cetus, the great whale or sea monster. The brightest star in the constellation is Beta Ceti or Deneb Katos, an orange giant located 96 light-years away. The name Deneb Katos means the whale's tail. Another one of the stars in Cetus is Mira, the first variable star ever discovered. Located some 420 light-years away, Mira pulsates in brightness over a period of 332 days, changing in diameter from around 400 to 500 times the diameter of our Sun. Also visible is Alpha Ceti, traditionally called Menkaure the Nose. It's a red-hued giant star some 220 light-years away. It's actually a double star, with a secondary 93 Ceti being a blue-white star some 440 light-years away. Also in Cetus, located some 11.9 light-years away, is the yellow dwarf star Tau Ceti, the nearest Sun-like star to the Earth other than the Sun. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and other characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. That's followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, then comes spectral type G yellow stars. That's where our Sun fits in. Slightly cooler are spectral type K orange stars, and then the coolest and least massive stars known are spectral type M red stars. Each spectral classification can then further be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then you add a Roman numeral to represent luminosity. So at the end of all that, our Sun is classified as a G2V, or if you prefer G25, yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but then became brown dwarfs after losing some of their mass. Brown dwarfs fit in a unique category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red stars, which can be 75 to 80 times the mass of Jupiter, or 0.08 solar masses. South of Cetus, you'll find the brilliant star Achernar, which means the river's end, and it marks the end of the river Eridanus. Achernar is a binary system, comprising Alpha Eridani, which is the brightest star of point of light in and lying at the southern tip of the constellation of Eridanus. The two components of Alpha Eridani are designated Alpha Eridani A and Alpha Eridani B, and they're located about 139 light-years away. Of the 10 apparent brightest stars in our night sky, Alpha Eridani is the hottest and bluest in colour. That's due to Achernar being a spectral type B main sequence star. Achernar also has an unusually rapid rotational velocity, causing it to be quite oblate in shape. The second star in the system is a smaller spectral type A white star and orbits the primary star at a distance of around 12 astronomical units. Follow Eridanus towards the east and you'll see the magnificent constellation Orion the Hunter, a familiar signpost for southern summer skies. To the west of Orion is the constellation Taurus the Bull, and located in Taurus is M1, the Crab Nebula. It's the remnant of a star which Chinese astronomers saw explode as a supernova on July the 4th in the year 1054. They recorded the sudden appearance of a new star on their sky charts at the exact position of the Crab Nebula. The supernova appeared brighter than the planet Venus for weeks on end, before finally fading completely from view after almost 2 years. The Crab Nebula is located some 7,000 light-years away. It's expanding at a rate of over 5 million kilometers per hour. At the heart of the nebula is a rapidly spinning neutron star or pulsar, rotating some 30 times every second. It's emitting radiation in all wavelengths, from gamma rays and X-rays through ultraviolet, optical and infrared, and on into radio waves. observations indicate the pulse's spin rate is slowing down, and it will fall to just half its current rotational rate in the next 1,000 years. November is also a great time to check out the Pleiades or Seven Sisters, one of the nearest and most spectacular open star clusters to Earth. Also known as M45, the Pleiades are located in the constellation Taurus. Now, depending on whose measurements you prefer, the Pleiades are located somewhere between 118 and 137 parsecs away, a parsec being 3.26 light years. The Pleiades are composed of mostly hot blue-white stars. Amazingly, different cultures in vastly different parts of the world all describe the Pleiades as seven sisters or seven women, possibly some sort of ancient throwback to very early human civilization. Just like October, November also sees 3 meteor showers. There's the November Orionids, as well as the Taurids and the Leonids. Although peaking in late October, the Orionids continue to sprinkle down during the start of November, and are usually at their best in the wee small hours before dawn. They're generated by the debris trail left behind by the comet Halley, and appear to radiate out from the direction of the constellation Orion the Hunter, hence their name. The Taurids are generated by the comet Encke, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Now, Encke and the Taurids are believed to be the remnants of a much larger comet which disintegrated sometime in the past 20,000 to 30,000 years, breaking into several pieces and releasing material by normal cometary activity and maybe occasionally through close encounters with the gravitational tidal force of the Earth and other planets. In fact, the cometary stream of material from the Taurids is the largest in the inner solar system, and being so spread out, the Earth takes several weeks to pass through it all. That means there's an extended period of meteor activity compared to the much smaller periods of activity for other meteor showers. Interactions with the giant gas planet Jupiter have also caused the Taurids to be segmented into separate northern and southern streams. The southern Taurids usually last from around September the 25th to around November the 25th, while the northern Taurids go from October the 12th to around December the 2nd. The Taurids are usually quite diffuse, only producing about 7 meteors per hour. However, they're composed of far more massive material. Think of pebbles instead of dust grains. And so they tend to produce a higher percentage of very bright meteors known as fireballs, produced by the larger meteoroids burning through the atmosphere. The southern Taurids should be putting on their best show just after midnight around now. The third meteor shower in November are the Leonids, which peak around November the 18th. They usually produce around 15 meteors an hour, but have been known to occasionally produce some spectacular meteor storms, with showers in 1999, 2001 and 2002 producing around 3,000 Leonid meteors per hour. But one of the best had to have been the Leonids meteor shower of 1966, which generated literally thousands of meteors per minute, falling like illuminated rain. The Leonids are usually picked up after midnight, with peaks occurring just before dawn. Produced by debris from the comet Tempel-Tuttle, the Leonids radiate out from the constellation Leo the Lion. And they're a fast-moving stream, encountering the path of the Earth at 72 kilometers per second. Larger Leonids, which are about 10 millimeters across, can have a mass of half a gram and are known to generate really bright meteors. It's been calculated that the annual Leonids meteor shower can deposit 12 to 13 tons of particles across the planet. Jonathan Nally from Sky and Telescope magazine joins us now for the rest of our tour of the November night skies.
G'day, Stuart. Well, where I live, we're heading towards summer. I live in the southern hemisphere, of course, so summer's coming up. The weather's becoming much nicer. The evenings are becoming warmer. Only problem is that for many of us, including myself, we've got daylight saving to contend with, so you've got to wait later in the evening for the sky to get dark. But, win some, you lose some. After the sun has set, we have a short window to get our last glimpses for the year of the mighty constellation Scorpius and Sagittarius. The front half of the Scorpion has already disappeared below the western horizon after sunset, but the tail end with the sting is still poking upwards into the sky, so you can still see that. If you're looking for the Southern Cross, you won't have much luck during the pre-midnight hours during November. At this time of year, it's upside down and either very low on the southern horizon or below the horizon, depending on which city you're living in and how far south you are. But if you're up and about in the hours before dawn, you will be able to see it. It will be lying on its left-hand side, sort of low in the southeast. So it looks like a pie shape, and it's quite small. The Southern Cross is actually the smallest constellation, so don't go out expecting to see something really big. If you hold your hand out at arm's length, you can cover it up. It's the smallest constellation. Now, if you have really dark skies, if you're somewhere where you don't have much light pollution, you might be able to make out a dark patch in the Milky Way right next to the Southern Cross. This is called the coal sack. That's its nickname, the coal sack. It's a huge region of interstellar gas and dust that's out there in space, and it's blocking out the stars of the Milky Way behind it. Originally, people thought, no, this might be a hole in the Milky Way, and we're looking straight through to the other side, but then they realised, no, it's just a big dark cloud in the foreground, basically, with the Milky Way behind it. There are some stars in front of the coal sack, so it's not completely black, but you do need some dark skies, country skies, or just away from light pollution in order to see that. In the early morning, if you're still out there looking for the Southern Cross, you should also be able to see two bright stars down near the southern horizon. These are known as the two pointers, or the pointers, because if you draw an imaginary line between them and then keep that line going for a short distance, it points more or less towards the Southern Cross. One of those two stars is the famous Alpha Centauri, and it's actually a triple star system and the closest star system to our solar system. It's only just over 4 light years away. Alpha Centauri is actually a double star. There's two stars going around each other very close, and the third star in this overall triple system is very, very small, very faint. You can't see it with the naked eye. You need a telescope and you need to know exactly where to see it. But it actually is the closest star to Earth other than the Sun. It's called Proxima Centauri. Now, in the evening, if you look in the southeast, you'll see a very bright star. This is Canopus, the brightest star in the constellation Carina, and in fact the second brightest star in the night sky. In colour, it is essentially white, although some people, myself included, think it has a slightly yellowish tinge. That's a combination of eyesight, and I think it does. It's not purely white. And also, very often when you're looking at it, it's down towards the horizon, so you're getting a bit of atmospheric murk in the way, so that tends to change its colour a little bit too. Canopus is about 310 light years from Earth, which is not very far in space terms. And like many stars, Canopus is huge. It's really big. It's not the biggest, but it's big. It's about 70 times, get this, it's about 70 times wider than our Sun, and it's more than 10,000 times brighter. And the only reason it's not as bright as the Sun in our night sky is because it's 310 light years away. If it was much closer, it would be just dazzling. Now, higher up above Canopus, you see another bright star, quite high up, in fact. It's called Achernar, and it's the brightest star in the constellation of Eridanus, a constellation most people have never heard of. It's the constellation of the River, and this is the 9th brightest star in all of the night sky. And one of its claims to fame, you can't see this, but the scientists have worked it out, is that it's spinning so rapidly on its axis is that its equator is sort of bulging out and the poles are flattened. It's not a sphere like most other stars, but it's become oblate, sort of flattened. So, yeah, stretched out around its equator and sort of squashed at the poles because it's spinning really fast. Now, as the evening is progressing and we get towards midnight, you'll see that the other half of the Milky Way is rising in the east because the beginning of the evening, the first half of the Milky Way, if you want to call it, is right on the western horizon and it goes down very quickly. But late in the evening towards midnight, you see the other half of the Milky Way coming up in the east, and it's bringing with it some of the best stars and constellations. For us in the southern hemisphere, we know this is the sign that summer is approaching. For our friends in the northern hemisphere, they know it's the sign that winter is approaching. So first, low down in the east, there's Sirius. And this is the brightest star in the constellation Canis Major, or the Greater Dog, and Sirius is the brightest star in the night sky. Around to its left a bit is the fantastic constellation Orion, with its many amazing sights. You've got these two bright stars called Rigel and Betelgeuse. You've got three little stars in a row that form the belt of Orion. Orion stands for the Hunter, so this is the Hunter's belt. And then hanging down from the belt are a couple of other stars and a fuzzy patch. Well, that is an enormous star-forming region, 1,500 light years from Earth. And it's just amazing that we can see these things just with the unaided eye. It really, really is. It might not look impressive, but when you think about what it is and what it is you're seeing, it's really quite remarkable. So that's around to the left of Sirius. So if you keep going further around the left, around to the north, we get to the constellation Taurus, which is pretty easy to make out because it has a wedge-shaped group of stars, a star cluster called the Hyades, and there's a bright red star there called Aldebaran. Not far from the Hyades and Aldebaran is another easily seen group of stars called the Pleiades, or the Seven Sisters. Now, if you get a pair of binoculars onto this one, you will gasp in wonder, I assure you, because it looks really pretty through a pair of binoculars. You don't even need a telescope. Seven Sisters is named because most people with average eyesight can make out 7 of the stars. There are actually hundreds and hundreds of stars in this star cluster, but most of them are quite faint. But if you get a pair of binoculars onto it, you'll see many more than you can with the naked eye. It really looks lovely. Now, let's look at the planets. Mercury is actually readily visible all this month, which is not common. Very often, Mercury is very low on the horizon, and only for a week or two, you don't really get to see it. But this month, fortunately, we're going to see it quite easily. You'll find it above the western horizon after the sun has set. So where the sun goes down, once it's gone down below the horizon and the skies are starting to get a bit dark, even in the twilight, in fact, you'll see what looks like a small, bright star, and that's Mercury, but it is, of course, a planet. It should be quite easy to spot. Higher up, sort of straight up from Mercury, is a much brighter light, and that's Venus. And you just simply can't miss Venus. It's so bright. It's actually brighter than those 2 bright stars I mentioned earlier, Sirius and Canopus. Now, Saturn is almost overhead for people like me who live at mid-southern latitudes. It looks like a medium brightness star in inverted commas, and it's got a yellowish tinge. And because it's so far away in space, it doesn't appear to move much from night to night. In fact, you really won't see any movement night to night because it's going so slowly through the night sky. And unlike Mercury, which you should notice has changed position as each night rolls around, you'll see Mercury from night to night. Mercury will have changed position a bit. It's got a bit higher, and then later in the month it'll get a bit lower. But Saturn, it's basically going to stay in the one spot and move with the stars as the Earth rotates. Now, if you're out stargazing after midnight and the wee small hours, maybe you're finishing a night shift or something, or you're coming home from a party, you'll find Jupiter, big and bright, not far from that star Aldebaran I mentioned earlier, actually. So Aldebaran looks red, and Jupiter's basically big, bright, and white. And this will be just above the northeastern horizon in the early hours of the morning. Mars will be there too, above the northeastern horizon, but not until after about 2:30 when it rises above the horizon. So if you're up around that time, you should be able to spot Mars. It's got a distinct ruddy colour, a sort of a reddish ruddy sort of colour, even a bit orangey, which makes it quite easy to identify. And it's quite a lot dimmer than Jupiter. Well, they're separated quite a lot in the sky in terms of the angle between them as we're looking at them, but you should be able to spot the two of them together. Jupiter big and bright, and Mars lower down, ruddy sort of colour and a little bit dimmer. And that, Stuart, is the sky for November.
That's Jonathan Nally from Sky and Telescope magazine. And this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.